Hello everyone. Today's joke of the day is for all you Star Wars fans out there. What do you call a droid that takes the long way around? Stay tuned to find out. Our learning target for today is I can solve a system of equations using any method. So let's quickly review the steps for solving each of these systems of equations using each of these methods. Okay, so the first method we learned was graphing. Now for this one, we want to make sure we graph both lines, and we want to look for the point where those lines intersect. Okay, this ordered pair, or this point, okay, the ordered pair that represents this point will be the solution to the system. Okay, so you want to graph both the lines, find the point where they intersect, and that's your solution. Okay, pretty straightforward. Now for substitution, we have a few more steps, okay? So the first thing we need to do is we need to double check and make sure that one of the equations has y or x by itself. So think it's something in the form y equals 5x plus 8, okay? Anything similar to that, y equals something. Now the other one could also look like that, or it could be written in standard form. Okay, this is, remember, what we call slope-intercept form. Okay, and then you want to replace or substitute, right? Take out, replace, substitute. Those are all synonyms. Replace the y in the other equation with the expression. Okay, so that's y is equal to in that first one. So for example, this 5x plus 8, this would be our expression, okay, that we would substitute in for y in the second equation. Okay, and then you're going to solve for x, and then substitute that value. Substitute that value back into one of the original equations to solve for y. Okay, and then once you know both x and y, you can write your answer as an ordered pair, and that will be your solution. Okay, and I'll go through an example of that in a little bit here just to remind you of what that actually looks like in practice. Okay. Then finally, the elimination method, we are going to add or subtract. Okay, we're going to add or subtract the equations together with the goal of eliminating one of the variables. Now, before we do that, you may first need to multiply one or both of the equations by some constant, some number, to get the same or opposite coefficient. Remember, that's the number that comes right in front of the variable, to get the same or opposite coefficient for one of the variables. Okay, so for example, you want to have 3x and 3x. Okay, these would be the same coefficient. Okay, and then we could subtract those equations to eliminate the x. Okay, and now once you've added or subtracted the equations together and eliminated one of the variables, you want to solve for the remaining variable. Okay, and then you'll do just like what we did with for the substitution method. Once we found one of the variables, you substitute that value back into one of the equations to solve for the other variable. And you will finally write your answer as an ordered pair, just like we did for substitution. Okay, so now we have to think about if we're just given a system and not told what method to use to solve it, let's figure out how we're going to decide. Okay, so here we go. We have a few systems, and we're asked to solve the systems of equation using any method that we have learned. Okay, so for this first method, let's first think about, okay, graphing. Well, the easiest way to graph an equation is if it is in slope-intercept form. In this case, we have one equation that is not in slope-intercept form. Okay, this second equation is not in slope-intercept form. So it's going to be kind of hard to graph that equation unless we solve first, but that seems like a lot of work. Let's check a different method. Now, this one we have one of our equations in slope-intercept form. So we have it solved for y. So actually, it seems like this would be a good one to use substitution for. Okay? Elimination would be difficult because we don't have both of our equations. I spelled that wrong. Okay, we're going to use the substitution method here. Okay, so like our first step says up there, we want to substitute this expression in for y into our second equation. So then we'll have 10x plus 7 times 2x plus 3, and that will be equal to -3. Okay, and now we just need to solve to get x by itself because we only have one variable. So our first step is going to be to distribute here. So we'll get 10x plus 14x plus 21 equals -3. Okay, and then we'll combine like terms. So we'll get 24x plus 21 equals -3. And then we can solve for x. So we'll subtract by 21 on both sides. We get 24x equals -24. And then we'll divide by 24 on both sides to get x by itself, and x is equal to -1. Okay, so we figured out x. Now we need to substitute that -1 back into our original equation. I'm going to use that top one because it's going to be simpler to solve for our y value. So we get y is equal to 2 times -1 is -2 plus 3, and then -2 plus 3 is 1. So y equals 1, and our solution we'll write as an ordered pair. That will be -1, 1, because our x value always comes first in an ordered pair. Okay, now let's look at this next equation here. In this case, we, again, both of our equations are in standard form, so those are going to be pretty difficult to graph. So instead of graphing, let's think about one of the other methods. Now we could solve to get either x or y by itself to be able to use the substitution method, but that would be not the first thing I would think of to do here. In fact, we have two equations and they're both in standard form. So I'm going to look at the elimination method here. Okay, and in order to do the elimination method, we need to have either the same number in front of our x or our y's. So think like both of the x's have a coefficient of 3, or they'd be opposites. So like the coefficient of 3 or -3. Now in this case, we don't quite have that. But if I look at this 14 and this -7, I know that 7 times 2 would be 14. So I just need to manipulate this second equation a little bit and multiply it by 2 in order to get an equation that we can work with. So I'm just going to rewrite my first equation because we're not doing anything with that one. 8x plus 14y equals 4. And then I'm going to multiply everything in the second equation by 2. So I'll get -12x minus 14y equals -20. Okay? And now I know that if I took 14y plus a -14y, that would give me 0y. Okay, so I'm going to add these equations together. Those will cancel out, and we'll get 8x plus -12x gives us a -4x, and that will be equal to 4 plus a -20, which will be -16. And then we can divide by -4 on both sides to figure out that x is equal to negative 16 divided by negative 4 is a positive 4. Okay, and now that we figured that out, we can substitute that 4 back into one of our equations. Let's do that second equation there. Doesn't really matter which one, you could do either. Oh wait, I need to substitute it in for x, not for y. Okay, negative 6 times, because that's what x is equal to, times negative 7y equals negative 10. And now we just need to solve for y. So negative 6 times 4 is negative 24, minus 7y equals negative 10. And then we can solve for y by adding 24 to both sides. Those will cancel out. We'll get negative 7y equals negative 10 plus 24 is a positive 14. Divide by negative 7 on both sides. Y is equal to negative 2. And then we can write our solution as an ordered pair. And it'll be 4, negative 2. Okay, let's look at one last example here. Now here we have two equations that are both in slope-intercept form, and there are two things that I would automatically think of here. Now this would be an easy one that we could solve by substitution, but we do have that 1/2 as a fraction in there, and that might be not as fun to deal with in substitution. So we could also graph this one because both of our equations are in slope-intercept form. So I'm going to say graph in this case, but you could also use substitution. Okay, but in this case we'll graph. And I'm going to graph the first equation in green, so I'll highlight it with green here. And we do that first by plotting our y-intercept, which is negative 2. And then we use our slope. So our slope is equal to 5 over 1. So we're going to go 5 is our rise and 1 is our run. So for every 5 that we go up, 1, 2, 3, 4, 5, we go over to the right 1, 2, 3, 4, 5, over to the right 1. You could also go down 5. And to the left 1. Okay, and that will be our first line. Okay, and I'll graph this second one in red here. Okay, so we'll also start at the point negative 2, and then our slope here is going to be 1/2. So we'll have our rise is 1 and our run is 2. So we'll go up 1 and over 2. Up 1 over 2, up 1 to the right 2, or we could go down 1 and to the left 2 because it's a positive slope. We want to make sure we're going up as we go to the right. Okay, oh, that's a really bad line. Let's do a little better here. There we go. Okay, and our final thing here is we want to find the point where they intersect, which is going to be right here on the y-axis. So our solution is going to be the ordered pair of that point, which is 0 in the x direction and negative 2 in the y direction. Okay, so that's just a quick review of each method and why and when you would want to use them. All right, and now for today's joke of the day. What do you call a droid that takes the long way around? R2D2er. Thanks for watching and have a great day.